Hey there, Lambo 404. Ever feel like the blockchain's open book is maybe a little too open?
Uh-huh.
Or maybe you're dreaming of building that next killer Web3 app,
Hmm.
but, you need to keep user data safe, secure, locked down,
Hmm.
while still playing by the rules.
Yeah, that's the tension, isn't it?
Exactly. So today on the deep dive, we're cracking open two uh, pretty fascinating projects cooking in the Cardano kitchen, Crypsinous and Midnight.
Right.
Let's figure out what they are, how they stack up, and, well, whether having both in the toolkit is really the future.
Absolutely. And these are definitely cutting edge. They're aimed right at, I think, a growing need.
Hmm.
How do we get real privacy and accountability into these decentralized techs?
Hmm.
We've got a great set of sources to unpack for you today. We've got the real nitty-gritty research papers on Ouroboros Crypsinous itself.
Okay.
Some really illuminating chats with Charles Hoskinson talking about the sort of big picture vision for Midnight.
Right, the strategic view.
Exactly. And articles that help us understand the different flavors of Ouroboros, which is kind of the foundation here.
All right, so our mission, should you choose to continue listening, and we know you will, Lampo 404, is to really gronk what Crypsinous and Midnight are all about.
Mm-hmm.
We want to see how they connect, within that Cardano ecosystem, and crucially, figure out if they're just different ways of tackling the same privacy nut, or if they offer maybe distinct, possibly even synergistic solutions for us builders and users.
Okay, let's start by laying the groundwork with Ouroboros Crypsinous then. Think of it as a specialized blueprint. It's core to the Ouroboros family, but specifically designed to build privacy right into the core.
Into the proof-of-stake core.
Exactly. Both in how the network agrees on things, consensus, and how transactions actually happen.
Right, so Ouroboros is Cardano's engine, essentially. That consensus protocol keeping everything running smoothly, securely.
Yeah.
Now, Crypsinous, as the research shows, it takes the really solid security and that leader election process from Ouroboros Genesis
The stake-based election?
and infuses it with the privacy superpowers of Zerocash, which, is famous for those zero-knowledge proofs,
ZK proofs, yeah.
letting you prove things without revealing all the details.
Yeah. Well, what's fascinating here is the balancing act Crypsinous performs. You
Okay.
see, the original Ouroboros, it relied on public knowledge of who holds what stake. That was key for the integrity of leader selection.
Right, transparency was the security feature there.
Precisely. Crypsinous pulls a really clever trick. Instead of openly showing their coin value, potential leaders produce a NIZK proof, a non-interactive zero-knowledge proof.
Okay.
It's like proving you have enough tickets to win the raffle, but without showing everyone exactly how many you bought.
Oh, okay.
The proof just shows, one, they meet the stake requirement, and two, crucially, that those coins haven't been used already. They're unspent.
So the key insight here is that for the first time, we could have the security of proof of stake without revealing who the big players are. That fundamentally changes how we think about blockchain transparency, right?
It really does. And because the stake distribution is now secret, Crypsinous needs a very specific way to handle transactions where stake might be involved. It can't just assume everyone knows the state of play anymore.
Makes sense. So how does it handle that?
Well, this leads to the idea of freezing stake in zero knowledge. Your coins are essentially split privately into two categories. You've got cleared coins.
For leadership.
Exactly. They can participate in leader election. And then C-SPEN coins, which you just use for regular transactions.
Okay.
And these are represented by cryptographic commitments and serial numbers. Think of them like secret digital envelopes that hide the value and the owner.
Okay, so these leadership and spending coins, they're tucked away securely using crypto magic. But if a leadership coin gets chosen to propose a block, doesn't its serial number get exposed during that NIZK proof? Sounds like it could be a potential chink in the privacy armor, no?
That's a very sharp question, a really good point. And the designers of Crypsinous, they anticipated this.
Oh.
To prevent that exact privacy leak, they implemented what they call a coin evolution process during leadership transactions.
Coin evolution.
Okay.
How does that work?
So when a leadership coin is used, it's effectively retired. It's destroyed.
Yeah.
And a brand new coin linked to the old one in a very specific deterministic way, but with a fresh serial number, is created.
Ah, so it regenerates.
Exactly. This new coin can then be used for spending or for future leadership roles. And because of this constant coin evolution, it's really vital that even leadership transactions on different branches of the blockchain are validated. Got to maintain that system integrity.
So the coin kind of sheds its skin and reappears in a new, untraceable form after its leadership duty?
That's smart.
It is clever, yeah. The research also mentioned something about using forward secure encryption for efficiency instead of non-committing encryption.
Right, this is a bit more technical, but the core idea is really about a practical trade-off. Non-committing encryption would be like the ideal for absolute privacy
Why is that?
because it makes it literally impossible for the sender to later prove what a piece of encrypted data contained. Total deniability.
Okay, sounds great, but...
But it can be very resource-intensive, heavy lifting computationally. So Crypsinous opts for forward secure encryption, which is more efficient.
How does that work then? What's the trade-off?
It works by making a reasonable assumption about how quickly data travels across the network. They assume a maximum delay, they call it MX.
Delta MX, okay.
And the security then relies on the idea that an attacker who manages to, say, hack a user at a certain time, they won't be able to instantly access their secret keys from that exact moment.
Right.
They'd only get the key they would hold after that network delay period, plus MX.
Ah, so there's a built-in lag assumption for the attacker.
Essentially, yeah. They're making a smart bet on how quickly an attacker can realistically move, which allows for a much more efficient system without hopefully sacrificing too much security in practice.
So the key takeaway for you is that this is a practical compromise. It's about getting better performance in the real world.
Exactly. Real-world optimization.
Got it. The paper also talks about the UC framework, universal composability, and some complex-sounding hybrid functionalities in their security model. What's the TLDR for us non-PhD cryptographers?
Okay, think of the UC framework as like the gold standard in security proofs.
Right.
It's a super rigorous way to show that Crypsinous behaves just like a perfectly secure, trusted system, even if there are malicious actors out there trying to mess things up.
Okay, so it's a strong guarantee.
A very strong theoretical guarantee, yes. And those hybrid functionalities, things like a perfectly reliable network or ideal encryption, they're just abstract tools used in that security proof to make the analysis simpler, more manageable.
So they're part of the proof method, not necessarily the real-world implementation details.
Exactly. The fact that Crypsinous has this kind of rigorous security backing gives us really strong confidence in its privacy and security properties under certain standard cryptographic assumptions, of course.
Solid foundation, then.
Yeah.
Now, what about the actual transactions? How does sending value work? It's mentioned that it uses a Zerocash-like system where you burn 2 coins to create 2 new ones when you make a transfer.
Yes, very similar mechanism to Zerocash. When you want to send value in Crypsinous, you essentially destroy 2 of your existing private coins.
Okay.
And you create 2 new ones, maybe of different values. One goes to the recipient, and maybe one comes back to you as change, all privately.
And the key part.
The important thing is that when you initiate this transfer, you have to explicitly say which of your private coins you're spending. You specify them.
Why is that so crucial?
Well, in a fully private system, the blockchain itself doesn't have a public record of who owns what, right? So you have to tell it which secret coins you're using.
Makes sense. And to make sure all these private transactions are legitimate, we're back to those NIZK proofs again, right? One type for electing leaders and another for making transfers.
Exactly right. 2 key uses. For the leadership side, the NIZK proof is like a signature of knowledge. It proves that the person knows about a coin that legitimately won the right to propose the next block.
Okay.
For transfer transactions, the NIZK proof is different. It demonstrates that the coins being spent actually exist within a Merkle tree. Think of it like a big, verifiable digital family tree of all valid coins. And it proves that the transaction is consistent, meaning, the value going in equals the value going out. No creating money out of thin air.
Right. Conservation of value.
And the paper also distinguishes between public and private actions, with these private transfer transactions being specifically marked, like public transfer.
Gotcha. And the main conclusion from all that heavy security analysis is that Crypsinous can achieve a truly private version of a general-purpose ledger, but with maybe one specific piece of information potentially leaking.
That's a key takeaway, yeah. While the transaction details, the amounts, who sent to whom, that all remains secret, the identity of the person, or at least the key that gets to propose each block, might still be observable.
Okay.
But look, that's still a massive leap forward from the full transparency of traditional public blockchains.
No doubt. Okay, so that's Crypsinous' deep foundational research into building a truly private proof-of-stake system. Really interesting stuff.
Definitely.
Now let's pivot and talk about Midnight. From those YouTube chats with Charles Hoskinson and reading the Night paper, it sounds like Midnight is taking these kinds of privacy ideas and aiming them squarely at real-world applications.
That's a perfect way to frame it, I think. Midnight is presented as a brand new blockchain technology. It's specifically engineered, it seems, to bridge that gap we talked about earlier.
The gap
Between the inherent openness of public blockchains and the critical need for data protection and regulatory compliance that, actual businesses and real-world assets demand.
Right.
The fundamental problem Midnight aims to solve is how do you handle both public and private data on the same decentralized platform without falling back on centralized off-chain solutions that kind of undermine the whole point of using blockchain for trust in the first place.
Right, because let's be real. Businesses just can't operate with everything hanging out in public view. They need confidentiality.
Absolutely.
So Midnight is trying to build a system where you can get the best of both worlds. The decentralization benefits, the trust, but with the privacy controls you actually need for practical use. The videos highlighted a few key technologies making this happen. First up, decentralized identifiers, or DDs.
Yes, DDs seem to be right at the core of Midnight's strategy. It's about combining identity and transactions, but preserving privacy while doing it.
How does that work in practice?
Well, the idea is you can associate a DD with your activities on the blockchain, like a transaction or a wallet, without revealing your actual real-world identity directly on-chain. And this is coupled with what they call non-reputable credentials, or non-creds. These let you cryptographically prove specific facts about yourself.
Like what?
Like, say, proving you're over a certain age, or maybe that you meet certain regulatory requirements for a particular transaction. But crucially, you do this without having to disclose any other personal information.
Selective disclosure.
Exactly. The Atala Prism framework was mentioned as a related project in this identity space. But the key insight for you, Lambo 404, is that you can interact with the blockchain in a verifiable way, proving what needs to be proven, but without just splashing your real-world identity everywhere. That unlocks a whole new realm of privacy-preserving applications.
It's like having a digital passport that only shows the specific visa needed for the situation, not the whole passport.
That's a good analogy, yeah.
The videos also talk about Kachina for private smart contracts. That sounds like a potential game changer for building privacy-focused apps, right?
Kachina is indeed positioned as a novel technology, developed specifically for Midnight. It lets developers create smart contracts with a really clear, deliberate separation between what's public and what's private.
Within the same contract.
Within the same contract. It's code, it's data. So you can define which data points, which steps in the execution are visible to everyone on the blockchain, and which are kept completely confidential, shielded.
And is it easy to use? Because complexity kills adoption?
Well, importantly for developers aiming for Lambo 404, it's apparently designed to be quite user-friendly. It uses TypeScript.
Oh, nice. Very popular.
Very popular language. So the idea is developers can build sophisticated applications and easily designate, what should remain in the shadows and what can be out in the light.
That's huge. Making privacy actually accessible to developers is absolutely key for widespread adoption.
Couldn't agree more.
And then there's this multi-resource consensus, MRC, using something called Minor. This sounds like it's all about Midnight playing nicely with other blockchains, right?
Yeah.
Interoperability.
Exactly. MRC and Mainor seem designed to tackle that crucial challenge of interoperability. The vision presented is for Midnight to act as a kind of service layer, a privacy and identity layer that other blockchains like Cardano, yes, but even potentially Ethereum can tap into.
How would that work? Give me an example.
Okay, imagine a DayX like Uniswap running on Ethereum. It could, theoretically, call into Midnight to handle, say, private trades between users, or maybe to ensure regulatory compliance for specific users, like those based in the US, by checking credentials privately via Midnight.
Ah, so it's a hybrid dApp model.
That's the idea, a hybrid decentralized application model. It allows users to benefit from Midnight's specific privacy features without needing to completely migrate all their assets or activity over to a totally new blockchain.
So Midnight isn't trying to be its own isolated island. It's aiming to be more like a universal privacy and compliance utility for the entire blockchain world.
That's the framing, yeah. A service-oriented internet of blockchains, as they put it in one source. It wants to be this sort of fundamental piece of infrastructure that any dApp can plug into for computational privacy and identity management.
Okay, that's ambitious.
Very. And the regulatory aspect is particularly interesting, I think. Midnight enables disclosure at the smart contract level.
What does that mean, practically?
It means there isn't some kind of universal backdoor key or escrow baked into the core protocol itself. Instead, it empowers exchanges or regulatory bodies or whoever is running an application to define their own compliance rules within the smart contracts built on Midnight.
So it's flexible.
Much more flexible, yeah.
Okay.
A potentially more globally adaptable approach to regulation rather than trying to hard code one set of rules for everyone.
This ability to selectively reveal information, then, seems like a major difference compared to something like Monero, which was mentioned in the videos as a comparison point.
Right.
Monero is all about purely anonymous transactions, full stop.
Exactly, whereas Midnight's ability to combine these private smart contracts with the DID system allows for this controlled disclosure. And that capability is seen as really crucial for broader adoption, especially by institutions, and for achieving regulatory acceptance beyond just, fully shielded anonymous transfers.
So it's trying to find that middle ground.
It's positioning itself as a platform that can cater to both users who value absolute privacy and regulated entities that need to follow certain rules. It offers this spectrum of disclosure possibilities through its smart contracts and identity framework.
The videos also clarified Midnight's relationship with Cardano. It's described as a partner chain. What does that mean exactly? Is it a layer 2?
Well, it leverages Cardano's established network and security, especially for its launch, but it's presented as operating independently. It's not strictly a layer 2 solution that's completely dependent on Cardano for its own security validation.
So it could run on its own.
Precisely. While Midnight clearly benefits from launching alongside Cardano and can leverage its infrastructure, it has its own consensus mechanism, its own tokenomics, and can function autonomously. And that independence is key to its vision of potentially offering its privacy and compliance services to a much wider range of blockchain ecosystems beyond just Cardano.
Got it. And then there's the tokenomics. We have Night as the governance token and Dust as the utility token for transaction fees. The idea behind Dust being non-transferable but constantly replenished, that sounds like an interesting way to tackle potential anti-money laundering concerns, often associated with privacy coins.
Yes, that separation seems quite deliberate. Separating the governance token, Night, from the transaction fee token, Dust, aims to provide predictable transaction costs for users.
Because Dust isn't speculated on.
Exactly. And it also mitigates some risks related to illicit activities. Since Dust itself apparently can't be transferred between users, its potential for use in money laundering is significantly reduced, while still allowing users to pay for actually using the network's computational resources.
Interesting design. Finally, the Night paper really emphasizes Midnight's architecture. You mentioned TypeScript for developer ease.
Yeah, that's a big one.
A compact programming language to keep things efficient and separate application logic from data, and the use of really cutting-edge ZK tech, specifically snarks using Halo 2 and these Pluto AI's curves.
Right, pushing the envelope on the ZK side.
It all seems geared towards making privacy and compliance technically robust.
Okay, so having taken this deep dive into both Crypsinous and Midnight, let's try and bring it all together for you, Lambo 404.
Yeah, let's connect the dots.
Ouroboros Crypsinous, fundamentally, is a specific, privacy-centric consensus protocol. It's part of the Ouroboros family. Its core innovation is really in how it achieves privacy at those fundamental layers of a proof-of-stake blockchain, the agreement mechanism itself, and the transaction system.
Right, foundational tech. And Midnight, on the other hand, appears to be a much broader blockchain platform. It has a more comprehensive vision for privacy.
It's definitely broader.
It's not just about private transactions, right? It's about private data, private smart contracts, privacy-preserving identity through DIDs, and all while actively aiming for that seamless interoperability with other networks.
Exactly. So while Midnight could potentially leverage a privacy-preserving consensus mechanism in the future, maybe one inspired by or even built upon, the principles pioneered in Crypsinous.
It's not necessarily using Crypsinous today.
Not explicitly stated as using Crypsinous itself, no. Its immediate innovation seems to lie more in its comprehensive suite of privacy-enhancing technologies, Katina, DIDs, MRC, and its strong focus on developer experience and real-world utility.
So it's like Midnight takes the cryptographic tools for privacy, maybe tools like those developed in Crypsinous, and integrates them into a user-friendly, interoperable platform. One specifically designed to meet the needs of businesses and regulatory requirements.
That's a good way to put it. Crypsinous is like the deep foundational research, laying the cryptographic groundwork for truly private blockchain operations.
Okay.
And Midnight is more of a practical application, a platform, taking those core principles and building a usable system for a much wider range of privacy-sensitive use cases.
Yeah.
That's an excellent analogy. Midnight represents a potential real-world realization of the privacy-preserving concepts explored in protocols like Ouroboros Crypsinous, but with a much broader scope. Protecting data beyond just transactions, which brings us back to the big question, do we need both? It sounds like maybe they serve different, but potentially complementary roles in the grand scheme of decentralized privacy.
I would argue that the answer is a resounding yes. We probably do need both.
Why?
Well, look, foundational research and protocols like Ouroboros Crypsinous are absolutely essential. They push the very limits of what's cryptographically possible in this realm of decentralized privacy.
They invent the tools.
They invent the tools. They provide the crucial theoretical underpinnings, the core innovative breakthroughs. Without that deep research, we don't get the building blocks for things like Midnight.
Okay, makes sense.
And then you absolutely need projects like Midnight to take those cutting-edge advancements, those new tools, and translate them into practical, user-friendly platforms that developers can actually build on and that can address the very real-world needs for privacy and compliance that we're seeing across pretty much every industry now.
Right. Midnight is about making these powerful privacy tools accessible and applicable, solving tangible problems, driving wider adoption.
Precisely. The need exists at both levels, I think. You need the robust, privacy-focused protocols, the tech foundation, and you need the application-oriented platforms that make these technologies usable and actually drive their adoption in the real world.
So they aren't necessarily in competition.
Not necessarily, no. They arguably represent different but equally vital stages in the ongoing evolution of privacy-preserving blockchain technology.
Okay, so to sum it all up for you, Crypsinous is a deep dive into making the core Ouroboros agreement mechanism private, foundational stuff. While Midnight is a brand new blockchain constructed with a much broader vision. Privacy and compliance for real-world decentralized applications, potentially leveraging innovations coming out of research like Crypsinous.
Well summarized. And
Yeah.
both are clearly tackling this crucial growing demand for greater privacy and regulatory adherence in the blockchain space. And as you think about what this all means, maybe just consider the transformative potential here. What could truly private and compliant blockchain applications unlock across different sectors? Think finance, healthcare, supply chains, even just managing our own digital identities online.
Yeah, the implications are pretty vast.
They really are. So we definitely encourage you to delve deeper, check out the white papers, follow the ongoing discussions around both Ouroboros Crypsinous and Midnight. It's a fascinating and rapidly evolving intersection of privacy and blockchain tech.